So, good evening, students. So,
Good evening, sir.
So कल एक होमवर्क दिया था मैंने, पर देयर आई डिड नॉट मेंशन द करंट वैल्यू, तो किसी का आंसर आया नहीं होगा. So in this homework, there was a 2 ampere current, as well as here there was resistance 2 ohm. Okay, so we'll quickly do it again today. So we can apply KVL here. Okay, so 30 volts is given. This is 8 ohm resistance and 2 ampere current is flowing. Okay, so 2 into 18, there is 16 volt, and remaining voltage will come here. Okay, so 30, this is 16, 14 will come here. So suppose this is V10. Okay, this is V10. So if I apply KVL, so KVL means this minus 30, okay, and this is plus minus, so plus 16, okay, plus V10 is equal to 0. This is KVL. Okay, in loop first. So this will give me V10 is equal to 14 volts. Okay, now इस पे जो V10 है 14 volts है, और यहाँ पर जो रेजिस्टेंस है वो 10 ओम है, तो करंट कितना हो जाएगा? सो करंट विल बी 14 divided by 10. This will give you 1.4 ampere. Okay, so 2 ampere is current coming here. Okay, in at this node, and out of 2 ampere 1.4 is going there. Okay, so remaining 2 minus 1.4, 0.6 ampere is going in 2 ohm resistance. Okay, so now my aim is to calculate Vx. Okay, so this is Vx, so I can apply now KVL in this second loop. So if I apply this KVL in second loop, so this will give me minus V10. Okay, this plus minus already Vx is already there. This will give me 0.6 into 2. Okay, this will give me 1.2 volts plus 1.2 volts and plus Vx equals to 0. Now V10 is already is 14. This is 14. This is 1.2 plus Vx. So your Vx will be now 12.8 volts. Okay, so this is the answer. Now today we'll discuss what is node analysis. So before discussing node analysis, let me quickly revise what is series and series resistance and resistance.
सर ये हमने जो बीच वाला जो 2 ओम का रेजिस्टेंस है इसको कंसीडर क्यों नहीं करा सेकंड टाइम पर?
किया ना इसको, फिर 0.6 into 2, तभी तो 1.
सर ये जो बीच में राइट में है जो
ये, हाँ, तो अभी हमको खाली Vx चाहिए ना. नाउ इफ यू, हमको यहाँ पे दिस इज पैरेलल, तो ये भी Vx ही है, तो हमको खाली Vx चाहिए, तो मैंने खाली Vx कंसीडर करा. अब चाहो तुमको करंट निकालना तो करंट निकालो, Vx पता है, तू पता है, करंट निकाल लो, यहाँ से फिर Ix भी निकल जाएगा. ठीक है?
यस सर.
हाँ सर. ओके सर, Vx का वैल्यू आपने कितना बताया था?
Vx का 12.8 वोल्ट्स.
ओके सर.
ओके,
यस सर.
सो अगर अब एटलीस्ट KVL तो तुमको क्लियर हो गया होगा. अभी भी किसी को डाउट है तो मुझे पर्सनली कांटेक्ट कर सकता है. KVL KCL कैसे अप्लाई करेंगे सर्किट के लिए. सो आई कैन अरेंज पर्सनल मीटिंग एंड वी कैन डिस्कस इफ एनीवन हैज डाउट. ओके, नाउ resistors in series. So resistors in series का मतलब क्या है? That resistances are connected in sequence in such a way that same current flows across all the resistors. Okay, so say this is R1, this is R2. Okay, say this is Rn. Okay, and here I'm applying this battery. Okay, V. So now here voltage drop will be V1. So this is V2 and this is Vn. Okay, this is plus minus plus minus plus minus. Okay, now we can apply KVL here. Okay, so if I apply KVL, so KVL will give me this V. Okay, V equals to V1 plus V2 so on Vn. Correct? If I apply KVL, minus V equal to plus V1 plus V2 plus Vn. So V equal to V1 plus V2 plus Vn. जितना भी वोल्टेज लगा रहे हैं वो सारा का सारा वोल्टेज रेजिस्टेंस, जितने भी रेजिस्टेंस लगे हुए हैं उसके अक्रॉस ड्रॉप होगा. ओके, नाउ I know, suppose I current is flowing in the circuit. I current is flowing. Okay, so I can write now my V equals to V1. V1 will be the same current है, so I R1, I R1, I R2, and so on, I Rn. Okay, so I can write V equals to I R1 plus R2 Rn. Okay, now this I can write V equals to I R equivalent. Okay, so if I replace these three resistance by equivalent resistance, okay, so this is my V plus minus R equivalent. Okay, so that means R equivalent is equal to R1 plus R2 plus R3 plus Rn. Okay, so that means in series the equivalent resistance is equal to sum of the algebraic sum of the resistances. Okay, so I can write my R equivalent is equal to R1. ये सब आपको पता ही है. I'm just for completeness I'm taking this part. Okay, now this is series. Okay, now what about the voltage drop in the series? Voltage drop कैसे calculate करेंगे? I want to calculate V1 V2. Okay, so how to calculate V1 V2? Okay,
sir, IR1.
IR1. Okay, so V1 will be IR1. Okay, और I कितना है? I कितना है?
V by R1 plus V by R equivalent.
Very good. Okay, so V by R equivalent. Okay, so where R equivalent is R1 plus R2 plus R3. Okay, so I can write this is as a R1 upon R equivalent into V. Okay, so this is V1. Okay, similarly I can write V2. V2 will be R2 by R equivalent V. Okay, and suppose there's a kth element Vk, so I can write Rk upon R equivalent V. Okay, so just to give you a number, suppose my R1 is 2 ohm. Okay, so R1 is 2, R2 is 3 ohm. Okay, and now I'm taking only 3 resistances. So say I have only 3 resistances. Okay, not any resistances. So I have one more resistance, R3, whose value is 5 ohm. Okay, and say this V is equal to 10 volts. So now what is the value of V1? V1 कितना होगा?
So 2 by 10 into 10.
So R equivalent is 10. Okay, R equivalent is 10. So I will be V upon 10 upon R equivalent. Okay, 10 by 10. So current is 1 ampere. Okay, so this current is 1 ampere. So this is, so drop will be current into resistance. So this will be 2 volts. Okay, here voltage drop will be 3 volts and here voltage drop will be 5 volts. Okay, so there's total 10 volts. Okay, so in series में क्या होगा? जिसका resistance सबसे ज्यादा होगा, okay, the voltage drop will be more in that resistance. Okay, यहाँ 5 ओम है तो सबसे ज्यादा ड्रॉप यहीं पे हो रहा है, तो करंट सेम है. ओके, नाउ लेट मी नो यहाँ पर पोटेंशियल कितना है? जैसे नोड, ये भी नोड है, ये भी नोड है. ओके, तो यहाँ पोटेंशियल कितना है? इस पॉइंट पे
10 वोल्ट
3 वोल्ट सेम वोल्ट
10 वोल्ट
10 वोल्ट यहाँ पे 10 है ओके यहाँ पर कितना होगा इन नोड पे वोल्टेज कितना होगा इस पे
8
8 ओके ना
8
8 यहाँ पर कितना होगा 5 5 ओके सो दिस इज 10 8 5 और यहाँ पे क्या ये 0 है is connected to minus so you should know so when we'll do node analysis okay in node analysis we will only consider this node voltage okay we don't need to calculate these voltages so their variable will be node voltage so if you know we can calculate the node voltages we can simplify the circuit okay so this was resistors in series now let me do for resistance in parallel so I have a source okay say V and I have resistances so R1 R2 okay and say total there are n resistances this is Rn okay and I current is coming here so out of I1 is going here okay I2 is going here and In is going here okay so because these resistances are in parallel okay they are connected on the same terminal so voltage drop across all the resistance will be same okay so I can apply KCL here because I current is coming and it is dividing in I1 or I2 plus In so I can apply KCL okay so it will give me I equals to I1 plus I2 plus I3 so on In okay so now I will be because voltage is same V upon R1 plus V upon R2 okay plus V upon R3 V upon Rn so now this I will be V common हो जाएगा 1 upon R1 plus 1 upon R2 plus 1 upon R3 1 upon Rn okay so this I can write V upon R equivalent okay where 1 by R equivalent is equal to 1 by R1 plus 1 by R2 and 1 by Rn okay so these things you know already now what about value of I1 I2 okay so this circuit the equivalent circuit for this circuit will be there will be one source V okay who's providing current I okay and the parallel there will be R equivalent okay so is equivalent now how to calculate I1 I2
The potential difference will be same. So sir, V by R1, V by R2 will give I.
so now to simply we can do it potential difference is same okay so I want I1 so I1 will be nu upon R1 okay और न्यू क्या है इसकी वैल्यू क्या है I total I into R equivalent upon R1
Yes sir.
okay similarly if I want to write I2 I can write I into R equivalent ये तो सेम ही आएगा only इधर आ जाएगा R2 okay if I want to write IK will be I R equivalent this will be RK So जितनी कोई कितने भी एलिमेंट ऐड हो, you can calculate what is the value of current if you know the R equivalent value. So I'll take a simple example जो हमको बार बार यूज होगा, two resistances. Okay, so I am taking this two resistance example. So this is I2. Okay, now in this circuit I want to calculate what is my I1. So I1 will be I into R equivalent. Okay, so R equivalent कितना हो जाएगा इधर? If two resistance are
R1
there,
R2 upon R1 plus
R1
R2.
R2 upon R1 plus R2.
okay, R1 plus R2 and divide by R1. Okay, divide by R1. So R1 R1 cancel हो गया. So I1 क्या हो गया? I1 आ गया I R2 upon R1 plus R2. That means R1 में कितना करंट फ्लो करेगा डिपेंड करता है R2 पे. ओके, दैट मीन्स आपको रेजिस्टेंस लेना है सेकंड वाला. अगर इसमें आपको करंट चाहिए तो आपको टोटल करंट लेना है. टोटल करंट इनटू रेजिस्टेंस जो सामने है उसका इक्विवेलेंट रेजिस्टेंस R2 डिवाइड बाय R1 प्लस R टोटल रेजिस्टेंस. सिमिलरली इफ आई फाइंड I2, okay, my I2 will be I R1 plus R2. तो इसको याद रखना है क्योंकि ये ट्रांजिस्टर सर्किट में बहुत यूज होता है जब पैरेलल में करंट डिवीजन करना होगा. सो यहाँ यू कैन सी हियर इफ R2 इज 0 तो I1 कितना हो जाएगा? इफ R2 इज 0 तो I1 आपका 0 हो जाएगा. इसका मतलब R2 0 क्या मतलब? इसका मतलब शॉर्ट कर दूं. इफ आई मेक इट शॉर्ट, ओके, 0 रेजिस्टेंस, देन विल बी, सो क्या होगा? सारी करंट क्या आएगी? जितने भी करंट आई है वो यहाँ आके फ्लो हो जाएगी, क्योंकि करंट विल ऑलवेज चूज द पाथ व्हिच हैज द लोएस्ट रेजिस्टेंस. So because here is no resistance, so full current will come here, and here I1 will be 0. Okay, so if you put R2 equal to 0, your I1 become 0. Okay, so your R2 is 0, your I1 becomes 0, and your I2 become I. Okay, so R2 0 cancel, I2 become your I. Whole current will pass through second resistance. Okay, similarly if I now make R2 open, अगर ये ओपन है, ओके, तो क्या होगा?
Infinite resistance.
तो रेजिस्टेंस इनफाइनाइट हो
I1
गया,
equal to-
R2 इनफाइनाइट हो गया. ओके, so it is open, so I2 won't flow, I2 will be 0. Okay, so if R2 is infinite, okay, your I2 will become 0, and your I1 कितना हो जाएगा? I1 हो जाएगा I upon R1 upon R2 plus 1, लिमिट लगा दे इस पे, R tends to infinite, तो ये क्या हो जाएगा? R2 tends to infinite, ये 0 1, तो I1 equals to I. वैसे भी अगर सारा करंट यहाँ पे नहीं आ रहा है, यहाँ पे करंट 0 है, तो सारा करंट इसी में फ्लो हो जाएगा. then your I1 will be equal to I. Okay. So this meeting is only for today for 40 minutes. Okay, I have to take बीच में बंद हो सकता है, so you have to tell me when this is 6:40. Okay, so we'll quickly solve one problem based on this current division. Okay, कि हमको इस सर्किट एनालिसिस में मास्टरी नहीं करनी है. ओके, because it is required for our work, so as early as possible we have to come to our syllabus. Okay, so now suppose we have 5 ampere current. Okay, and then we have this, we have one resistance more. This is 10 ohm, this is 15 ohm. Okay, so this is I1, this is I2. Okay, so calculate I1 कितना होगा? कितना होगा
So
I1?
3 amperes.
I1. Okay, either आप ये फॉर्मूला यूज करो R इक्विवेलेंट वाला, या फिर I1 चाहिए टोटल करंट कितना आ रहा है? 5 एम्पियर इनटू सामने वाला रेजिस्टेंस 15, ओके, प्लस टोटल रेजिस्टेंस 25. Okay, so this will become 5, so this will become 3 ampere. Remaining I2 and I2 will be your 2 ampere. So if you have two resistance, you can use this formula. Otherwise, you remember this formula: I total I into R equivalent upon जो resistance है उसका वो resistance R1. Okay, so this was for two resistances. Okay, एक 4 resistance वाला भी कर लो, so that you should remember. ये formula ज़्यादा आसान है. ओके, बिकॉज जो करंट चाहिए वो रेजिस्टेंस टोटल करंट इनटू आर इक्विवेलेंट. जितने भी रेजिस्टेंस सर्किट में है उनका आर इक्विवेलेंट निकाल के रख लो पहले से ही. ओके, सो नाउ दिस इज 3 ohm now. Okay, this is 6 ohm. This is 9 ohm, and we have one more 12 ohm. Okay, so this is I1, this is I2, I3 and I4. Okay. Calculate what is I1, I2, I3. So first of all, you have to calculate R equivalent. Okay, so 1 by R equivalent will be 1 by 3, 1 by 6 plus 1 by 9 plus 1.12. Okay, so this will become 12. कितना हो जाएगा?
36 by 25.
कितना आ रहा है? R equivalent कितना आ रहा है?
36 by 20.
36 by
25.
कितना आ रहा है क्या? ठीक है, 36 ओम आ रहा है, सही है. अब निकाल लो I1 I1 I2 R1. Okay, so I1 now, I1 will be, okay, I5 into R equivalent 36 by 5, okay, upon R1 is 3. Okay, 5 cancel हो गया, 25. So this is 25, so if 5, so this is 12, so 12 by 5 ampere I1. ठीक है. Similarly I2 will be
1.2 amp.
this is 5 ampere coming, RQ 36 by 25, resistance is 6, so ये हो गया 6 5. Okay, 6.5. Okay, 1.2 amperes. And your I3 will be again 5 into 36 upon 25 divided by 9, so 4, so 20 upon 25 or 4 by 5 ampere. ठीक है, चेक कर लेना. And similarly, I am writing directly I4. So I4 is your 3 by 5 ampere. So you can solve it this way. Okay. Now we'll see how to perform node analysis in the circuit. Okay. इसको रब कर दो ना.
Yes, sir.
Now put the heading node analysis. So now I'm giving you circuit. Okay. So this is 28 volts. Okay, this is 7 volt. This is your 4 ohm. Okay, let's say R1. Here we have R2 value is given 2 ohm. It's R2, and here is R3. R3's value is given 1 ohm. This 1 ohm, R3. Okay. Now I want to solve this circuit by node analysis. Okay. So node analysis के लिए first of all we have to find nodes. Okay. यहाँ पे कितने node है? This is 1. This node 1. Okay. This node 2. This is node 3, and this whole is a single node. Okay. Node 4.
Node 4.
Now, okay. So node analysis में क्या करते हैं? We will try to calculate values at nodes. तो ये भी अभी 2 loop circuit है. Okay. So if I write KVL, I can write 2 equations. Okay. But nodal analysis में फायदा क्या है? With only 1 equation you can solve this circuit. तो कैसे? So this is node 1. So this voltage already we know. Okay. So here we can see this is my, so what we'll do, there's four nodes, 1 2 3 4. So out of these 4 nodes, 1 node will be taken as a reference. Okay, reference मतलब ground. तो suppose ये वाला है, इसको मैं ground ले लेता हूँ. तो जो भी माइनस से कनेक्टेड हो या मल्टीपल टर्मिनल कवर कर रहा हो, उस नोड को आप ग्राउंड ले लो. ओके, सपोज ये मेरा ग्राउंड हो गया. Now with respect to this node, I will calculate the values at these nodes. Okay, now this is already known because it's connected to 28. So I already know. So no need to calculate this one also. Okay. Similarly, this is calculated. This is ground, and this is connected to 7. So this is already 7. This is already 7. So I don't need to solve this one. Okay. So only I require this node B. Say the voltage at this node is V. Now I want to calculate only this voltage. Okay. So node analysis में क्या है? Node analysis means KCL plus Ohm's law. आपको KCL लगाना है और Ohm's law लगाना है. Okay. Now I have to analyze this node. This node पे जो बचा हुआ नोड है, इस पे मुझे KCL लगाना है. Okay. तो KCL के लिए मुझे करंट चाहिए. Okay. So current, suppose this is one current is coming here. Okay. This current is going here and this current is going here. Now यहाँ पे कोई भी चॉइस नहीं है. You can randomly choose any direction. Okay. आपको चाहिए तो ये करंट को इधर कर दो, इस करंट को ऊपर कर दो, इसको अंदर कर दो. Randomly जितने भी possible composition है. Okay. You can try everything, but your answer will not change. Okay. I'll tell you why. Okay. So suppose now only you know this is node. So node पे आने वाली current is equal to going incoming current is equal to outgoing current. Okay, that you have to remember, and then you have to decide whether you are taking outgoing currents as a positive or ingoing currents as a positive. This thing you have to decide first. Okay, so suppose I am taking incoming currents as a positive. Okay, and outgoing current is a negative. So this is the point, say P. Okay, so at P, okay, apply KCL. Okay, so now suppose this is I1 current, this is I2 current, and this is I3 current. Is it visible हो रहा है ना? I1, I2, I3.
Yes, sir.
Okay.
Yes.
So now just apply a simple KCL. Okay.
Yes.
So this is I1. This is I1 coming here. This will be positive. Okay. So I1 will be positive. Okay. Now this I2 is going from away from this one. You can also take this is also you can take this negative also. It is your choice. Okay. I'm taking incoming positive and outgoing negative. So this is my I2. Okay. Similarly, this is my I3 equals to 0. Now you know I1, I2, I3 की वैल्यू कहाँ से लाएंगे? Ohm's law से. Okay. So this voltage V, this 28. So 28 minus V upon R1 resistance. Okay. This is 4 ohm. Minus I2. So I2 का है? I2 will be going this direction. ये इस डायरेक्शन में है, मतलब ये हायर पोटेंशियल है. So higher to lower. Now current is going in this direction. That means this is higher. Okay. So I2 is V minus, this is 7. Okay. 7 upon R3, 1 ohm. sorry, R2
Sir,
this one.
that one you are writing is I2
Yes.
is
Yes,
below,
yes.
na?
Yes, 2. Okay, and I3 will be V minus 7 upon 1 ohm. Okay, 0. Now you can solve it and you can calculate the value with V. So if you calculate V, okay, कितना आ रहा था चेक करो. So this is
6 volt.
कितना
6 volt, sir.
6 volt. एक बार चेक करो अच्छे से. I don't think 6 है. 4. So 28 minus V. Okay. So this will be minus 2V. Okay. And this will be 4 minus 4V. Okay. Plus 7 equals to 0. कितना आ रहा चेक करो.
7 का भी तो multiply.
I am doing mistakes. Okay,
So
somewhere.
7 का
This is wait. So
तो 7 की मल्टीप्लाई होगी 4 से.
okay.